Hello friends, today's question. Two identical spherical balls of mass m and radius r. Each are stuck at on two ends of a rod of length 2r and mass m. As in figure, the moment of inertia of the system about the axis passing perpendicularly through the center of the rod is. So this is a rod of length 2r and we have two spherical balls which are stuck at the end of the rod, and we are supposed to find out the moment of inertia about this axis. Let us call this as OO prime for this entire system. So let's first of all find out the moment of inertia of the rod with respect to the axis OO prime. So you can say moment of inertia of the rod about the axis passing perpendicularly through the center. So you can say this is, let us suppose, is given as I rod with respect to center OO prime, axis OO prime, and this formula is our 1 by 12 ml square, where L is the length of the rod. Now in the question, the mass is m, so but the length of the rod is given as 2r. You can say but length is equal to 2r. Therefore, we can say moment of inertia of the rod about the axis OO prime will be equal to 1 by 12 mass into 2r square. And we solve it, this will be coming as 4, and ultimately it will be 1 by 3 mr square. Now we are going to find out the moment of inertia of the spherical balls which are stuck at the end of the rod. So as it is symmetrical, we are going to find out only for one sphere and multiply it by 2, and we are going to get the answer then. So first of all, let's find out the moment of inertia of the spherical ball about its own center. You can say moment of inertia of spherical ball about its center, and let us suppose that is given as I sphere with respect to center is given as 2 by 5 mr square, where m is the mass and r is the radius of the spherical ball. Now we are going to use theorem of parallel axis and find the moment of inertia of the spherical ball with respect to OO prime. Using theorem of parallel axis, and first of all we are going to find out what will be the distance between the center of the rod and the center of the sphere. Okay. So this is our rod, length is 2r, so this distance will be r, and we have sphere whose radius is also r, so this is also r. So the total distance between the axis OO prime and the center of the sphere is our 2r. according to the parallel axis theorem, we can write that moment of inertia of the sphere with respect to the axis OO prime will be equal to moment of inertia of the sphere with respect to center plus mass and distance between the OO prime and the axis of this sphere, and that distance is given as 2r whole square. So we already know I sphere with respect to center is 2 by 5 mr square, plus this will be also coming as 4 mr square. Therefore we get I sphere with respect to axis OO prime is equal to 22/5 mr square. Now we are going to find out the moment of inertia of the system. Okay. You can say moment of inertia of the system about axis OO prime. We can write this as I system about the axis OO prime will be equal to I rod with respect to OO prime plus moment of inertia of the sphere with respect to OO prime. And we have two spheres and both are symmetric with respect to the center of the rod, so we are going to multiply it by 2. So I rod, we got this as 1 by 3 mr square plus twice, and we got the sphere with respect to axis OO prime is 22/5 mr square. Mr square we can take as common, so we will left with 1 by 3 plus this will be 44/5. So 15 will be the LCM. Mr square, we have 15 and this is over 5 plus, and this will be coming as 132. Therefore you can say the moment of inertia of the system about the axis OO prime, which is perpendicular and passing through the center of the rod, will be equal to 137/5 mr square. Sorry, 15, not 5. So means this is the moment of inertia about the axis OO prime, which is perpendicular and passes through the center of the rod. So if we check the options that are available with us, so we have option number A is the correct option. Option A is correct. So this completes the question. Thank you.